So let's start. Hello, everyone. Sorry for the slight delay. It's like technical difficulties. It's like technology never does that to you, right? But finally, we have the whole crew here. Nelly, that's the most important, is connected. We also have Colin on the line, Alessandro, and Craig. And today we're going to be talking about serverless flexibility with Azure Functions. A little bit about ACSUG again. This morning, I just looked at the page and we are over 500 members for something that is really just concentrated on integrations, a lot of people. We've been organizing the Global Integration Bootcamp here in Auckland since it started in 2016, I think. On the leadership team, we have Craig Hayden, Colin Ggraf, Mike that is not with us today, me, Alessandro Moura, and Will Valida that didn't join it yet, but I think he might join. The way that you can help, and is that we always looking for help, is you have something interesting to talk or something that maybe you don't even think that is that interesting to talk, but you want to talk about it. Talk to us, because the chances are that is going to be something that a lot of other people is also interested. Or you wanted to know a little bit more about the topic, let us know and try to hunt a presenter for you. And raise your hand if you wanted to help with organization. Will, for example, just sent a message a couple of weeks ago or 3 weeks ago, and now he's part of the organization. You can follow us on Twitter on ACSUG_NZ, and now you can subscribe to our YouTube channel, right? So please go and subscribe. This is where we keep in all the recordings, and that recording after we finish, we're also going to be putting there. On today's show, we have flexibility with serverless on Azure Functions, and it's going to be presented by Nelly Sattari. She's a tech leader at Challenge Limited and Challenger Limited, and also Azure MVP, right? Not going to spend a lot more time talking about Nelly because she's going to present herself, and we are a bit little over. We have a couple of ACSUG legends, right? The first one is Nelly's joining us all the way from Sydney today, so thanks for that. And maybe that's accounts for the difficulties. I don't think so. I think it was more me. But this is the third virtual event that we are running this year, and the fifth in a row. Craig, is that a record?
I think it is. Yeah, even from Thiago's days.
Exactly. So we finally managed to get into a pace. In this case, the coronavirus helped us a little bit because we finally managed to get that running online. And for the next ones, we try to get a mix of virtual events and hybrid events. We're going to try from now on to always get the option for online events, because doing that, we can bring people like Nelly to the fold and join us from afar. So with that, it finished my initial regional talk, right? And not going to be putting my camera on. Nelly, are you okay to go live?
Yeah, sure.
Okay, so I'll send you live right now, and when you're ready to share your content, just share, and I can start to put that on the meeting.
Let me actually share my screen first.
Yep.
Did you mention where the fire escapes are, Wagner, just in case anyone needs them?
No, I didn't. It's on port 80 and port 8081.
Do you see anything on my screen?
We can see us.
Yes.
Do you see my slides or?
There we go. Now we do.
Yes, and I just pushing that live, and I also going to add your video on the side, make it quite professional. And ready to go.
Beautiful. Hello, everyone. My name is Nelly Sattari, and I'm a tech lead from Challenger company. I'm based in Sydney and really happy to join you in Auckland. This is my first time, and I was supposed to be there in person, but due to this situation, I canceled all my trips. So still happy to be with you. I am, as I told you, I'm a developer and tech lead at Challenger and Microsoft Azure MVP as well. So I'm going to talk to you about flexibility with serverless and specifically using Azure Functions for that purpose. This is Sydney. I already introduced myself. And let me tell you a little bit about the agenda. So we are going to talk about the like Azure Functions in general, and then the flexibility and the integrations that it will bring for us. Sorry, there is a bit of issue on this slide. Yeah, there we go. Okay, so I think a couple of months ago, I had a debate with someone on why I like to use Azure Functions and serverless. And that person was insisting that why we need that? We don't need that. Everything can be done through the app service, and potentially they're kind of, same concept. So why you need that? And the more I was thinking, the more I realized that what I love about serverless is more about the flexibility that it brings to the life, especially for the developers. And I want to share with you that perspective. So different opinions about, serverless. Some people love serverless because they feel, they save money, they pay as they go. It means that they don't need to up and run the long-running VM and, kind of servers on the Azure App Service and pay every day for the thing that they don't even maybe not use it. So maybe your customers and consumers just hits your service every couple of days, and you don't need to really pay for your service every day and every second. So that's why some people love Azure Functions, because you pay as much as your consumers hitting your service, which is a fair point. The reason is serverless is basically relies on the containers. It means that when you call your function, basically a little container, a lightweighted container will spin up, execute your function, and after that it will go away. And you only pay for the duration that your service is up and run. And it kind of, just help you get rid of that misleading word, serverless, because it's not really serverless. It's a container that basically it's up and run on the server, execute your command, but the thing is you don't know what is inside the container. You don't know if it's Linux based, if it's Windows based, how much RAM it has, how much hard it has. So you don't care about the details. You just execute your function. Another thing that many people like it about serverless is you basically can get your idea quickly into the market. And by market, I mean sometimes you want to do a POC, a proof of concept. You just want to show people how these things work without wasting your time and spending a lot of time on configurations. That's not important at this stage for you. You just want to get your idea into the reality. And that's why serverless really can be helpful. Another reason is microservices and basically event-driven architecture. So with microservices, we know that we potentially aim to have everything as a small piece of work, like every function, every API, every piece of code should be basically a little bit of separated, isolated piece of code, and then you just ship it alone, you ship it standalone, you just, spin it standalone. You don't have anything else to do with the other functions and pieces of work. And that's why many people really enjoy using serverless and Azure Functions as well. One example is, for example, user just pop into the website, upload a file, an image, let's say, and then pass it through the blob storage. The blob storage pass it through the function. The function resizes your image, and your image will be sent through the SMS, integrated with the Twilio, for example, service to your customers. So you can imagine millions and thousands of these scenarios that you can, connect everything with each other quickly and just get small pieces of code, all of them work together, and you just kind of, apply a nice big solution with using small pieces of work. However, having said all of these, for me, the flexibility that the serverless bring is the priority. And we all know, especially with this situation, that how much, flexibility is valuable. And when I say flexibility, I'm talking about different aspects of flexibility. One of them is the language that you are using. So with some services that I'll show you in this demo as well, like you used to not even be able to use those services if you weren't ASP.NET developer. Why you should have done that, right? So you could be flexible and adaptable and comfortable with any language that you want, and you still should get all the benefits that other developers get with different services. So Azure Functions give us this flexibility that we can be comfortable with any language, and basically we choose that language for writing our code. The build, test, and deployment, all the way from the local environment to the production, it can be easily, transferred from each stage to the other stages. I've worked with other applications, and like, for example, I want to use a service in the cloud. I have to install all the SDKs, connecting my local to the different services and replicate them on my local, which is not a really nice experience. But with Azure Functions, you actually can get on your local, you connect to this Azure and all the services directly without any pain, and then you can test your function, you can publish it exact same as what you have in your local. So there is a tool which is called Azure Function Core tool, and I really like it. It's just so powerful, and it's really helpful. So please look at this later on if you have time. And then I provided a little bit of, working with this Azure Core tool in my local to show you how it works. So basically, you just say run function init. It initiated a new function app for you. You choose what language you want. You choose basically your detail, and then you run the function new. It will create a new function for you. And then you just need to say how I want to trigger my function. Is it going to be, HTTP trigger? Is it going to be timer? Is it going to be like a file that user dropped into the storage, or whatever you basically need? And there are every day are new triggers, which we go through and talk about it later on. And you can see that 2 files are created for you. One is actual function, and one is a configuration, which basically tells what is the triggers of your function. And you just say function start, it will spin up your function in your local, and you can easily hit your endpoint. After all, you just run function publish, and then it will push your function with all the details that, like the even local settings that you have on your computer to the Azure portal. Then you can go to your portal and you can see your function is up and run. So it's a really nice experience, to be honest. And I use other serverless applications in different platforms and cloud providers. None of them are really, as a pointed developer, none of them was really as easy as this Azure Functions to me. And I had a weblog I show you here. So I just put all the details that you need to get up and run with the Azure Functions. So all the commands and steps with most of the troubles that you might face. And the troubleshooting parts, the references, everything is in this weblog. I can't potentially go through all of this in this session, but feel free to have a look and let me know if you had any question on my Twitter handle. Well, Another flexibility other than, this language and the other stuff that we talked, like testing and development experience, is the integration with other services and resources in Azure. This is an interesting thing. So I would like to show you by example and the demo, because it's just make it more sense. I'm not sure if anyone is online and you can try it or not, but if you are, scan this code. It would be an interesting thing. So probably when you read my profile, you can realize that I love conferences, especially IT conferences, especially the ones who are very inclusive, like fun and informative and really, as I said, inclusive. So in some of the conferences, when I attend, I'm extrovert. I don't have problem talking to people, but I can see lots of people are, a little bit shy, and they are just, standing in the corner of the room, not talking to anyone. And that's a really sad experience for me, because I feel that's a great opportunity to connect to people, talk to them, and, just get to know more people in the industry. So when I was watching that scene, that someone, like on the corner, looking at the mobile and playing around with the mobile, I was thinking maybe we should have an application in the conferences. And when people, pop into the conference, they just scan this barcode, and then I show you what happened after that. So basically they scan the barcode, then they pop into the website that I provided and published into the Azure. Then they take a photo of themselves. After they took the photo, which I show you the details how it works, we actually push the photo to the AI service in Azure. The AI service will kind of analyze your face based on your feeling and your appearance, and then basically broadcast your attribute to everyone who are in the conference, which is, for example, this person looks like that, they have glasses, they have this color of hair, and some features on your face. And the interesting thing is, it's going with your name and your character type, and that's a good excuse, because you can go around the conference and say, oh, this looks like you, John, for example, because I can see all the features on this application similar to you. So I realized that, like, ice breaking is the problem that some people have. They don't know how to start and where to go. So this is a good opportunity to just get to talk to people. That's a door, right? And after that, you can talk about anything you want. So I wanted to quickly come up with a demo and like a POC, and I didn't want to waste my time on different services, getting app service, setting up the server for myself. I just wanted to quickly get a Azure Functions, and that's it. So the way this works is through the website, which is a Vue.js front-end application. You just upload your photo. The photo will sit in the Azure Blob storage. Azure Blob storage, your photo will sit there. When you press the button to analyze your photo, the actual image from the blob storage will pass to the function, which is the face detect function. And through a HTTP request, it will be triggered. And then your Azure function will, it has built-in service to call the APIs. So you basically call the Azure Cognitive Service endpoint, pass your image is analyzed, it will send back your results to the function, and then through the function, you actually broadcast it to everyone through using Azure Signal Service. So basically, I just have one function, and you can see how much things I've done. I broadcast things to my users, I analyze my photo, and I upload it to my blob storage. And I show you how it works. So basically, these four services in Azure, what I used: Functions, Signal Service, Cognitive Service, and the Vue.js. This session, maybe it's a good opportunity to get introduced these two services as well. They are kind of interesting services. So I'll show you the magic of integration and how one function can basically talk to other resources through just, like two hands. There is a productive programming model in Azure Functions, which is based on triggers and bindings. Triggers is the way that a function will get invoked. So it can be different services that I'll show you. And the binding is how a function connects to the other functions. Remember my demo, the actual image which is processed is passed through Azure Signal, which is, through this binding basically. So you kind of connect your function with other services. This list in the Microsoft website is the list of basically triggers and bindings. So for example, the blob storage can act as trigger as well as binding, input, output. It means that when you upload a photo in the blob storage, it can be a trigger to your functions. And same, like it can be outbinding. It can be a kind of like the next step where your Azure function pass the data to the Azure blob storage. Similar to that, you can see all other services here, like for example, signaler, timer. So timer cannot be outbinding because what you want to pass to the timer, but it can be a trigger. Every 10 seconds, for example, make a call to my endpoint. Twilio, it makes sense. It cannot be trigger, how it can trigger a function, but it can be output because it's a SMS service manager. So you just pass through your result and response to the Twilio. Event grid is just interesting bit that you can potentially, I don't know why I lost my share screen. Oh yeah, cool. Event grid is another service. Basically, you can use it to, it's a really interesting topic because you can use it to connect all the event-driven and microservices together. So you basically pass the event and you're saying that this function, for example, place an order, and you pass it to the event grid. And then through that, it actually get your order and pass it to another binding. So all of this, you can go through and see how different services works. And like before we get to the Azure function to show you how it works, I would like to walk you through both services, Azure Signal Service and Azure Cognitive, so you get some familiarity with these services. So Azure Signal first. I'll give you some intro how this work and what it is. So you know that all the applications which are based on notifications, they really need to work based on real-time functionality. You cannot send a message and the message is going and disappearing. You have to get it immediately to the user. So any kind of like applications like Facebook, any notification applications, even the Uber, when you track your cab, or you just leave your package with them to ship it anywhere. Any online gaming, you cannot even have 1 second delay, otherwise you will lose. Or any kind of dashboard, an incident dashboard, which you need to see the incident immediately. For example, during the COVID-19 or even fire incidents and many kind of urgent dashboards that you need to see the events real time. They all need to use real-time functionalities. And real-time functionalities, the main components that helps us with having this functionality in the website is Signaler. Signaler is basically a kind of open source library which was shipped by ASP.NET initially, like maybe 10 years ago. And they just modernized it, and I'll show you how it's modernized. The way it works, it's basically working based on the WebSocket protocol. So it means that when user connect to your server, the HTTP connection is no longer valid. It's just converted to the WS protocol, which is WebSocket protocol. And the user basically stay persistently connected to the server. It's not like it get back the response and go away. It's not like that. So, and it has like two-way bindings support. So the user can send data to the server can pass it back to the, all connected users. And the way, like traditionally, the connection between client and server was like so tightly coupled. They were connected. It means that when we had, like when users getting a lot more than server capacity, we had to scale up, and this persistent connections takes a lot of resources, like including memory and CPU. That was a bit of problem, like the scaling for the Azure Signalers was a bit of problem. That's why many people didn't have enough interest to use that. However, with this new service, Azure Signal Service, it's actually worked as a proxy. It means that there is no more, like connectivity between server and client. When client connects to the server, it's not like persistently connected. Clients send a request to the server, which is all good, but then we'll get back the URL of Azure Signaler Service, and then we'll connect to the Azure Signaler instead of server. Basically, this Signaler Service sits between client and server, and whatever user pass to the Azure Signaler Service, it will pass it to all the servers who are scaled up or not. And then the server can pass it again through the signaler back to the users, which is an amazing feature, because normally if you don't use this signaler service, you go through a lot of process, like setting up your basically backplane for your servers and so much trouble. The way you can create your signaler service is just so trivial. You can run the command, or this is the Azure CLI command. You can use ARM template, or you can go to the portal and create your signaler service, similar to all other services. When you run your command, you can come to the portal and confirm that your service basically is created. So you search for signaler service, you find your recently created service. You can see all the detail about this, like keys, log system settings, and here is the setting that you can see. It can be classic or it can be serverless, and all the properties. Here we need to get the keys because we need to use it in our Azure Functions. That's why I showed you this bit. Well, I'll show you how to build the Azure Cognitive Service as well. It should be so similar. So you basically search for a cognitive service, and through Cognitive Service, you can find a lot of services like face detections, bot services, voice, and many other things. I selected the face service from the marketplace, and you can, like easily assign a name to that and identify the location, the price tiers, and all these things. When the service is created, you can get the endpoint and the key. Interesting things about these cognitive services is, as a developer, I just need to have an endpoint to connect to that cognitive service. This is how it works. So basically, you create your service and it will give you the endpoint, which is the API. So you can easily call your face cognitive service as an API, which I show you in the function. Well, here is the diagram, and I think I show you already this one. So you basically pass your image and it will upload it to the Azure Blob storage. You will trigger your function. The function call the endpoint that I show you, and send back the response to the function again, and the function will send the result to all connected clients through signaler binding. And this one, I can show you the function app. So the function that you create on your local, and I show you, you can start it, you can initialize it, and you can publish it. So after the publish, you can come to your function app and you can find your created function. This is the code of your function, and this is the interesting part, which is the integration. So basically you say my trigger is kind of HTTP and my output is, for example, signaler. And you can like test your function here. You can change the authentication, configurations, and even this configuration is interesting thing because you just deploy all the local setting kind of keys and configurations from your local to Azure function. And all these keys are secret keys, which sits in Azure Key Vault. And Azure Key Vault and Azure Functions are kind of connected. So this is interesting. All the keys are secret and protected as well. Well, I'll show you how to build the actual Azure Functions now, which is our target state. So I told you each function has one JSON file and one index like JS file, basically. When I say JS file, I mean, I am more comfortable with JavaScript, so that's why I chose JavaScript as the language of choice, but you can use C#, you can use any other language, and your file will be changed based on your choice. But this JSON file is something that you can kind of tell your function how you want to trigger your function and how you want to output your binding messages to different services. So in my example, I can show you that the type is HTTP trigger, which means like the API hook. And the method is, for example, post. You can have get, post, whatever. The direction is identifying is it the trigger or is it the binding. So when you say in, it means that the trigger, when you say out in here, you mean like the binding. So this is how we integrate Azure Functions with all the other resources. And you can have multiple, outputs at the same time. You can pass it to the signaler at the same time to the Twilio, at the same time to the, like blob storage, wherever you want. And this is the basically body of my function. So as I told you, you created your Azure Cognitive Service, you get the key and endpoint, right? And I kind of keep my keys and endpoint in my local storage, in my local machine. And you can see that I get my key and endpoint. Then I use Axios. Axios is a library to call like other APIs. I actually use the Axios post to make a call to that cognitive endpoint. And then here in the cognitive parameters, I can tell the cognitive service what kind of attributes I want you to analyze in my image. I told them that I need the age, gender, smile, like the hair, the glasses, any kind of makeup, accessories, any kind of emotions, and the hair color. There are a lot more. You can use anything that you want. And basically, I pass them as header as data, not header. And then that's it. I just make a call to my cognitive service, and then basically it I get back my response, and then I form a new kind of parameter for my signaler, because the signaler needs to know what you want to pass, first of all. Second is what client method is actually listening to your call. So the client is kind of connected to your website, and they're persistently connected, and they're listening, keep listening to see what you send to them. So here is the event listener that I need to identify that my client is listening to. So basically I say my target is this method, and my argument is the response that I get from the Azure Cognitive Service. And the most important thing is the context.bindings.signaler messages. So you can have any kind of services after this binding, context.binding.blob storage, event grid, or anything else, Twilio. So this is the way you introduce the signaler one. And then that's it. So another thing you need to have for this particular demo, which is the signaler, is the negotiate function. So basically, I told you when the client connects to the server, they definitely need to kind of stay connected and get the URL of Azure Signal Service. So through this negotiate function, which is another Azure function, you can get the URL of your Azure signaler, and then client can connect to that one. So the way it works is client connect to the Azure Functions, and then the messages are going to be broadcasted. As I told you, the negotiate is required. Otherwise, client doesn't know how to connect to Azure to the Azure signaler. I have another example here, which is again working based on Azure Functions and Serverless. So let's say you have a flight dashboard and you want to see all the flights, which is just landed in your dashboard all over the world. Unfortunately, these days we don't have that many flights, but I have already my demo from before. So you can see that the clients are like customers connect to this website. And every few seconds, they just get the most recent flight, which is landed with all the details about the flight, and their screen is just get refreshed automatically. This is interesting. I still use Vue.js as the front end, which is just a simple one-page application. A negotiate function, so client basically connect to the Azure Signaler, and they stay connected, waiting for, listening to the event to see what would happen and what would be the next message. And then at the same time, I have a kind of timer, which is connecting to the flight center and make a call to their API, get the message, populate it in the storage, and then pass it to the Azure Signaler. I'll show you the diagram. So basically, the third party through a timer, which is another function. I have a function which has just triggered by timer. That's it. Every milliseconds it will get called, and then the response from the third-party API will sit in my queue or blob storage, whatever. Then the queue acts as a trigger, so it will call my broadcast function, which is another Azure function, and my broadcast function is basically push all the messages to my signaler output and signaler broadcast it to the users. This is the typical scenarios that you can use. And here I can show you again the function app to make sure that you have it in your mind. So same scenario, you can see the endpoint of this function. You can see all the activity logs, and the log system is really helpful and it's really handy. And you can see I have a negotiate function and I have a broadcast function as well. And I have that timer to get the flight as well. So yeah, my trigger is the queue and my output is signaler, which is interesting. Well, again, my JSON file, easy. You can see that my type is queue trigger and my direction is in, which means trigger. And my output is signaler with the direction out. So I showed two examples to, just completely get the concept. And then if you go to your portal, you can see everything visualized. So you have your broadcast function, which I showed you, and you can see the triggers and output as well. So if you look at the actual body of your function, again, you can see, like this is even simpler than the other one. Your queue basically pass the response or data to your function through this parameter, queued flight. And then you just change your format of your message. You kind of introduce the message that you want to send to everyone and the event on the client side that user is listening to. And then connecting your output binding. So I talked about serverless with you and the whole purpose of using. For me, as I told you, it's more about the flexibility that it gives us. And other than that, it's more about the integration functionality and options that it will give to the developers and to the solutions, basically. So through that integration, you can connect all the services easily to each other. And the point that I don't want you to miss it is you don't need to download any SDK for SignalR or, you know, like Azure Q or other and kind of resources, because you can easily connect from your local to the actual Azure resources. Something that you might not be able to do it with all the, you know, like other kind of applications, if not Azure Function. And you have to download and kind of emulate your other services in your local. But with Azure Functions, you don't have to. You don't have to install anything. You just add the bindings that you want in your code, and then that's it. So this integration is something that gives us quite a lot of flexibility, so you can kind of connect your services to each other. Then you can move through the microservice pattern, because you just, you know, get the message, pass it through the other services, and every function just do one small thing, which is the whole purpose of microservices, basically. And in some demos that I showed you, we actually looked at how we can integrate the Azure Blob Storage, Azure Cognitive Service, and Azure Signal Service to each other through the function in the middle as a, you know, central main point. And that's the whole thing I wanted to talk with you. And I left some time for questions if you have any. And thanks for listening to me. I hope you enjoyed. And yeah, please reach out to my Twitter if you have any question, and I can help, or I can introduce you to someone if I couldn't. So yeah, please feel free to reach out. And that's it. I pass it to you, Wagner.
Are you still there, Wagner?
I was here, but I was on mute because there is a little one that is stealing power bank. But I'm back.
All right.
All right. Just let me put that screen up for questions. We have a question here that is kind of a mouthful, right? And Greg, you've been the designated MC. So can you read the question? Well, yes.
I saw the chat happening with Will. So where was the?
Maybe I can see the chat as well, right?
Thinking about a multi-cloud. Oh, is that one? Thinking about the multi-cloud architecture in the future, and not being too heavily tied into a single service from a single provider. Trying not to get too locked in. Okay, so vendor lock-in on that for the. Have you considered placing these services purely into Docker or Kubernetes containers instead of functions to be vendor independent? That is an interesting one.
I knew that these two questions will pop up. I'm so happy these two questions came up. So for the first one, the multiple cloud providers, yes, that's my problem as well. So you kind of tightly couple to this service, and you cannot really, I couldn't find a way that you can, you know, like push it exact same to AWS or other services, because they don't support this kind of integration functionality. So I would say no, you cannot. But the thing is, Azure Functions provided a new feature, which is, when I say new, it's kind of new. It's a function on container. So you basically, and that's not only it's good for multi, you know, like clouds, it's also good for another purpose, which I tell you. So you can potentially run your Azure Functions fully on the container, and then you ship your container probably to the other cloud providers. I haven't done it, but I investigated and I saw that that's the way you can do it. And another purpose of this kind of container is, for example, a few months ago, I had a kind of client that I was talking to, and they weren't on the cloud, like fully on the cloud yet, but they were on the journey of moving to the cloud. So they were kind of setting up their infrastructure to move to the cloud. But at the same time, they wanted to go on with writing their functions, and they wanted to have like a multi kind of microservices architecture. So they didn't want to wait for the cloud to be ready. And that was the solution. So they could easily run their Azure functions on the containers. And, you know, like when everything was set up and ready for going to the production, then they could kind of ship the container, Azure on the function on the container to the production, which was a nice solution that they used. So that's the one. And yes, as I told, I have the same problem. Another thing is like using container instead of Azure Functions is a good idea, but I don't think you can have exact same integration flexibility with the container unless you tell me there is a way. But I don't know if there is. I don't think so.
I'm not sure if the question from the OP, and he might have put a follow-up there. If it was like, instead of putting everything in a function, it got the impression that all those services was actually embedded in the function, while it's actually you have the Signal service in one place that you could easily replace with another binding if you needed to, or you had the cognitive services that could be replaced by your own Python model sitting somewhere else. And the thing that the function was giving us kind of the orchestrator, connecting all of those, but without you having to understand exactly how each one of those services work together, because you had that abstraction layer that was the binding. So for me, I think that's exactly what you were talking here around flexibility with serverless. The bindings are the secret sauce of functions, and the functions being able to run on containers, and some of those other components also be able to run on containers, give you the best of both worlds. You have the easy way to create, because the code that you showed us was awesome. You could do that in kind of a couple of hours, and it's not a trivial service to implement, but it could be done in a couple of hours. And now you could like package everything and put it on your cloud of choice, as long as you also be able to push that in containers. Was a great way to play with that.
Yeah, exactly.
So I guess one of the main things there is you're investing additional time into moving away from the goodness of functions to then make it more multi-cloud capable, right? Theoretically, but it's
if you really need to be multi-cloud, yes.
Yeah. Because all the technology still works within .NET, right? Signal is part of the .NET core capability. It's not anything special about Azure.
No, to be honest, the Azure Signal Service came around to decouple your dependency from the ASP.NET. So this Signal Service basically helps you to write your code with JavaScript, which was a great step for Signaler. So you don't have to be ASP.NET. Yeah, I had to like kind of summarize my Signaler talk here, but yeah, that's a really interesting topic, Signaler service, and the way it's just, you know, like helps you to get rid of all the traditional problems and getting into the new way of writing your code.
And funnily enough, here on the comments, Daniel Scott Rainford, there is a ex-MVP now on Microsoft is saying exactly that, like part of the great value of functions is in the bindings. But if you run functions in containers in Kubernetes, then you lose much of the function's goodness in a way. Well, you don't lose that much of the from a binding point of view. Like I think as the bindings are still the part of the fabric of the function runtime. But you would lose the easy ability to, I already have a service running somewhere, I just connect into that. Trying to put everything or trying to reinvent the wheel and push everything together again on something that functions already does is the bit that I see a little bit counterproductive.
Plus also with the containers, correct me if I'm wrong, you're actually paying for all the compute and processor and while the container's alive.
Oh, that's a good point, yeah.
Right. So when it comes
down
to
Azure Functions is on the consumption-based pricing model.
Yeah.
So then you're paying for always on containers as opposed to per trigger function.
That's true.
And Anonymous that sent the message just say awesome, thank you. That really helps. So I think we discussed the right things.
Yeah, and another point other than the consumption one is the scaling point. So basically with the Azure Functions, it's auto-scaled. So you don't need to go and say, you know, I want to have this much scaling. It will automatically scale. But with the containers, I think you have to identify your pods and nodes and probably manage them yourself.
Yeah, there's got to be something in there about Signal R as well, right? Because it's creating all the web sockets, and if you come back and you route it to a different container, that breaks your signals.
That's a good point, because Signal R has its own kind of scaling. So you basically scale this Signal R by units, and each unit can take, I think, thousands of connections. So basically, when the connections reach out the limit, then the Signal R service will kind of scale out. So yeah, you need to keep in mind that one as well.
All right. So there is a new. No,
from
there
Dan?
is no. Yeah,
I
there is
published
no
it.
new
Sorry.
one. Ah, there's another one published, right?
Yep.
Ah, yeah. So Daniel was saying that Project Osiris allows containers at 0 pods, which can get closer to Azure Functions consumption. So now we go. If we started to discuss that, we're going down to the Kubernetes a rabbit hole really fast. But thanks for that, Daniel. I think we might bring you in sometime to talk about that. Actually, I'll publish the link that he sent, because he sent a good link about that one.
Beautiful. It's good to know.
All right.
And like you said, closer, right? Not quite.
Yeah.
Watch the words.
I haven't actually seen that. I'm busy looking at that link now.
All right. So doesn't seem like there is any other questions there, and we just get into 6:30. It's probably going to be the first time that you finish on time.
That's good.
Yeah, it's usually because I talk too much, but I keep a bit quiet this time.
I'm not normally allowed to talk. It takes even longer. And just to call out, in the conversations and the live event Q&As, I have been trying to post all the links that you've mentioned. So your Twitter handle, your blog site. Yes, I think those were the only two major ones. And then also that Microsoft article about working with the toolkit functions.
Yeah, cool.
So
Core
I've got that link in there too.
Beautiful. Yeah. And please post my Twitter as well, so we can in touch with New Zealand guys.
Excellent.
Yeah, so Twitter is there, right?
Yeah.
Yeah, cool.
It's the second message in the,
Exactly.
Scroll up, fourth message in the Q&A.
And as soon as we get this ready, I'll be publishing that on the ACSUG channel. I'll make sure I'll send you a link as well.
Thank you so much.
Okay, thank you very much for coming all the way to Sydney, even if it's virtually. And hopefully next time it's going to be in person.
My pleasure. Yeah, I enjoyed. Hopefully see you in person as well. Have a good night.
Okay, thank you.
Thanks for sharing.
Thanks, everyone.
Cheers.
Thanks.
See ya.
Thank you.
Good job, Will, in finding the